Sam and Dean were able to weaken the ghost just enough to give one final blow and allow us to learn another bit of information. That is what happens when we have complex, multi-step reactions. In complex reactions, a non-spontaneous step can be driven by a spontaneous one if they are coupled together. So coupling means we are pairing reactions, one of which is going to release enough free energy for the other one to occur. We could also say that a spontaneous reaction is going to release enough free energy for a non-spontaneous reaction to occur. To couple also means we can use Hess's law to sum delta G values of a system and get an overall delta G naught. Let's look at an example. Here we have a zinc solid is going to form zinc solid plus our sulfur solid. The delta G is equal to 201.3 kilojoules. Again, we have a non-spontaneous process here. This non-spontaneous process is going to be coupled with sulfur solid plus oxygen gas to form SO2 gas, giving us a delta G value of negative 300.1 kilojoules. So again, this is a spontaneous process. We're going to be coupling them together to form an overall reaction. So to form this overall reaction, of course, we're using Hess's law. We have to get rid of things that are the same on both sides. That means we're going to have ZnS, which is going to be brought down. O2 is going to be brought down for the reactants, and then Zn solid and SO2 is going to be brought down for the products. Then we must go ahead and sum together our delta G values. So we're going to take our delta G1 and going to add it to our delta G naught of 2. So our overall delta G naught is equal to 201.3 plus negative 300.1 kilojoules, which is negative 98.8 kilojoules, meaning because we coupled this non-spontaneous process with the spontaneous one, we were able to make an overall spontaneous process. Or in other words, we were able to force this non-spontaneous reaction to occur. Another thing that's necessary for coupling to occur is that the coupled processes must be physically connected so that the transfer can happen between them. When we're looking at these reactions here, they both must be so close to one another that an actual coupling process can occur. And then once they are coupled, we can go ahead and see the overall delta G naught. But if they're not in physical contact with one another, this whole free energy transfer is not going to be able to happen. Many biochemical reactions are non-spontaneous and are driven by coupling with the spontaneous reaction. One example is the production of ATP. ATP is simply going to be considered cellular energy for this example. And this cellular energy is used for muscle contraction, cell transport, general energy for metabolism or synthesis, and even more. All right, folks, let's get to the coupling part of this. Now, ATP is going to spontaneously hydrolyze into ADP. Now, hydrolyze means that you're going to use water to break down. So you're going to use water to break down and go from ATP to ADP. And this, of course, is going to release energy and be spontaneous. Now, let's talk about the non-spontaneous part. The one non-spontaneous example could be breaking down food for energy. So one food molecule could be glucose here, which is non-spontaneous, and it's going to have to couple with ATP, which is spontaneous, so that we can continue to use our food as energy. The question now becomes, how do we get this spontaneous and non-spontaneous process to get close to one another? Well, in order to do that, we use an enzyme. And enzymes have active sites. So these active sites are going to allow for our ATP molecule and our glucose molecule from our food to become close to one another so that it can be used to, again, couple this reaction. And coupling glucose with this ATP is going to make this overall process spontaneous. And also, it's going to release ADP again. This ADP molecule can then combine with phosphate to regenerate ATP. So the continuous cycling from ATP hydrolysis to ADP, and then from ADP accepting a phosphate back to ATP, ensures a constant energy supply for our cellular function. This means that this ATP can be coupled with another process ensuring constant energy supply. We can easily visualize that here. We have food coming in that's breaking down that needs to be coupled with ATP. ATP is going to be used to form ADP. ADP is going to accept a phosphate to reform ATP that can then be used for other processes like muscle movement or muscle contraction. All right, we did it, folks. We stopped the chaos in Mystic Falls and saved Tammy and Micah. Now it's time to close the veil so this supernatural thermodynamic force never comes through again. This will take us into layering information about free energy, equilibrium, and reaction direction, allowing us to use this concept in a broader context for future hunts. See you there, folks.